It's like, well,
Okay.
Okay, right triangle trig. We're talking about trigonometry that works only with right triangles. It's brought up through this new way of dealing with finding measurement of an angle. The measurement's usually found through using sine, cosine, and tangent. Those are our main trig functions, but we have three others that we'll talk about in a little bit. When I look at a triangle, right triangle, I can look at an angle being phi or an angle being theta. Those are your two main ones. Doesn't mean your only options, but those are your two main options that books usually throw in there for angles. They use usually phi and they usually use theta. Okay? When they talk about two angles, they usually use both of those. When they talk about one angle, they usually just talk about theta. Okay? So theta is like the default angle that they go to. Alright, so when you have a right triangle, you're set up with a base angle that you're looking at. In this case, we're looking at theta. Okay? And from this base angle of the triangle, we have some things that we have to figure out. We have two legs, and we have one hypotenuse. Okay? So we have to figure out the hypotenuse is always across from the right angle. So that's easy. It's always that leg. Or it's always, the hypotenuse is always across from the right angle.
all right.
That's easy. It's the legs that get confusing. Okay? Because two legs, I got to know which one to grab. So, the one opposite of the angle you're looking at is the opposite leg. The leg opposite of the one of the angle you're looking at is the opposite leg. The one touching the angle or creating the angle that you're looking at from the hypotenuse, the one creating it, that is your adjacent leg. It's adjacent. It is touching the angle. The opposite is not touching the angle. The adjacent leg is touching the angle. Okay? So, with that, we come up with this right triangle trig called SOHCAHTOA. And SOHCAHTOA is basically the sine of theta is equal to the opposite leg over the hypotenuse, or SOH, S-O-H, which is really S equals O over H. And in this case, sine of theta is equal to A over C. Okay? Then you have cosine, ca. Ca is C-A-H, or in other words, C equals A over H. In other words, cosine theta equals the adjacent angle over the hypotenuse. So in this case, the adjacent angle is B, but the hypotenuse is still C. So it's B over C. Then we look at tangent, or TOA. TOA is T-O-A. So we got T equals O over A. So now you have the tangent of theta is equal to the opposite leg over the adjacent leg. In this case, the opposite leg of theta is A, and the adjacent leg is B. So tangent theta equals A over B. And that's SOHCAHTOA.